method number 2. In our method number 2, we do something different. So what is the main difference? The difference is pay for some cost to organize data. In our first method, we didn't do anything to organize given data because we feel if we do some work to organize the given data, we need to pay for the cost. All right? Yeah. So we want to save on that part. Okay? Yeah. But our method number 2, we are willing to pay for that cost. Okay? We're willing to pay for that cost. All right? Yeah. So look at that. We treat that kind of pay as investment in data structure. Organized data, so, you know, we choose some special data structure to help us organize the given data. Okay? Yep. Because after that, we expect to have some nice property or wish to have. Okay? We don't know if we can find wish to have some nice property. We know this kind of nice property is not free. All right? You need to pay for it. It's not free, okay? But we treat that pay as investment, okay? Yeah. Because we need to get some reward back for that pay, okay? Yeah. Yeah. All right, so let's look at the details of this method. The first step, we sort the given array first with certain cost. When you sort given array, you need to spend some time. You need to do certain number of comparisons, actually large number of comparisons when you have many elements. So the pay is pretty big, all right? Yeah, not cheap, you know, not cheap, usually pretty expensive. So that cost relatively high. Okay, all right. Yeah, so here I like to give you a formula. Yeah, sorting an element. We later we will learn many sorting algorithms. Here I just take the result. Okay, yeah. Take from later result. Okay, later result. The best we can get to sort a general array by comparisons n log n. N log n. We know approximately, okay? This expression approximately, but very close, okay? N log n. Yeah, that is the cost we should pay for sorting the given array. Okay, yeah, that's our investment. Okay, that's relatively high, not free. All right, but after the sorting, what do you get? What nice property you can enjoy, right? Some nice property we want to take advantage of. So we want to enjoy that nice property in our second step, right? Yeah. All right. Yeah. Here, more discussion later regarding the, how to get this formula, right? That part, we will address it. Later we have a lot of discussion on this formula expression. So don't worry. So here we just apply it first. Okay. All right. Question. How to check if any elements is repeated in an ordered array? This is the, that nice property we can enjoy. Yeah, because this property is so big for our solution. All right, for our solution, because after sorting this time, we have this sorted array. All the elements are arranged in increasing order, ascending order. Okay, yeah. So this time, we just work on the organized data. Okay, all right. Then checking the duplicates in this ascending ordered array. Can we do much faster? Right? Can we do much faster? Right? Yeah. So how do you check when you do comparisons? All right. Observation. All right. Yeah. We only need to compare two adjacent elements. Look at this adjacent. Because based on this, the property, if there are two elements in the array that have the same value, then we can find two adjacent elements that are equal. How about that? That's our observation. That's our observation. So do you agree with that observation? Right? Yeah. So that's the code. Yeah. So before that's the implementation code. I think we can understand the implementation easily. Yeah. But let me write that observation first here. Okay. All right. When there are two elements there are two elements with the same value. Okay, yeah. We can find two adjacent elements in the sorted array with the same value. Okay, yeah. So that's our, key observation. Okay, yeah. So here, the reason I write this sentence in this special way, because we try to consider all the possibilities. Okay, yep. Two elements with the same value. So when you sort the array, so it's not necessary that these two values are JSON. We do not say that. We do not say that these two elements should be adjacent. We do not say that. Okay. We just say we can find at least two elements with the same value, but they are adjacent. All right. Yeah. So we try to, make our statement rigorous. Okay. Rigorous. Yeah. All right. Yeah. Here, the answer. Yeah. So if you only do the comparison on adjacent elements, then the number of comparisons should be much smaller than before, right? Yeah. Here, the implementation and the solution here. Yeah. So here I wrote the solution. Yeah, but this number is covered. That number is n-1 comparison. N-1 comparisons, because you only consider adjacent pairs, right? How many adjacent pairs do we have? N-1. Think about that, n-1 comparisons. Okay, so you compare with the, old way, so old versus new. Old way, worst case, you need this many comparisons. New, you need n-1. Is a big difference? Think about that. Big reduction in number of comparisons, right? So think about that. That improvement, huge improvement. Yeah. But don't forget, we paid that cost before. Okay. That cost, we know it's not free. That's a pretty high cost. We pay that. All right. So that's the second part cost. So the total cost, that's the total cost of this method equals data organization cost plus the comparison cost. That is the total cost. Okay, that is the total cost. Okay, yeah. And method 1 total cost, method 2 total cost. We compare these two, but that will be our part B. Our part B, I will do comparison on these two expressions. Yeah. Today we will not do that. Okay. Today we just find two solutions. We will not do that. Okay. All right. Yeah, I have 2 minutes left. So before I finish my presentation today, so let me give you summary, the last sentence for the summary of this method. Okay, our method number 2. Yeah. Summary. Okay. All right. To get a better solution, how do you know we have a better solution? Yeah. So in our part B, we will do comparison. So you will see our method 2 is better than method 1. Okay. Method 2 is much better than method 1. Yeah. So here, the conclusion, the summary, to get a better solution, what we did to get better solution. Okay. We change the global comparison to local comparisons. Right? Global comparisons. Yep. So method one, we need to compare any two elements in the array globally. Okay, globally. So the locations of those two elements could be anywhere in the array. So that's the global type comparison. But here we only do two adjacent comparison. Adjacent we treat as the local way, right? Adjacent means local. How about that? Okay, that kind of change can help us reduce the number of comparisons greatly, big time. Okay, in big time, right? Yeah. All right, that's it. Yeah. So let me stop, finish my presentation right here.